This lesson is on variation and problem solving. Variation is when we're given one type of variation. There's two different types. And the first type we're going to look at is when we're given a linear function in the form of f of x equals kx or y equals kx. This is a straight linear function, so k is kind of like the slope of the function, and we're not adding anything. There's no y-intercept here. Well, we say that this type of a function is a direct variation, and that's important, that word direct variation. Also, we can say that y varies directly with x, which is kind of like saying that as x gets bigger, y will get bigger. As x gets smaller, y will get smaller. And we have to suspend this notion of negatives and positives, and negatives being smaller. It's that they get bigger negative or a bigger positive. We also talk about this letter k, which actually represents a number, and that number k is the constant of variation. So an example, this would be a equation that is an equation of variation, y equals 3x. Any x you put in there, if you put in a 2, you get 6. If you put in a 3, you get 9. So as x keeps getting larger and larger, y keeps getting larger and larger as well. Typically in variation problems, we're given some data, we're given some information saying, I have this relationship between x and y, and we are told that it's a direct variation problem. We plug it in and calculate for the constant. We keep it as a k, calculate for the constant, and then we're able to write the equation of variation, which you'll see in just a few moments. So, first of all, let's look at some examples, just real-life examples of what direct variation means, some situations. So the first situation is the cost of a vacation and the number of days of vacation. Typically, as you have more days of vacation, it's going to cost you more and more for that vacation. How fast you swim a lap in a pool and how often you practice. Typically, again, the more often you practice, the faster you will get swimming laps. The less you practice, you will not be swimming faster. Your GPA changes with the number of A's on your report card. As you increase the number of A's, your GPA goes up. As you decrease the number of A's, your GPA goes down. So here's an example of how we would actually calculate things with using variation. It says find the constant of variation and an equation of variation where y varies directly. It tells you that it's a direct variation with x, and then it gives you some data. When y equals 8, y equals 8 when x equals 20. So we're going to use the data, that the y equals 8 and the x equals 20, to solve for k. So we plug it into the equation with using all the variables, so 8 equals k times 20, and now we can solve for k, which is the constant of variation, and we need to simplify that 8 over 20, and we get that the constant of variation is 2/5. Now that we have the constant of variation, we can write the equation of variation, y equals 2/5 x, and that's the end of the problem. Now, let's look at a different type of variation. This time, instead of given a linear function, we're going to be given a rational or fraction function. And it'll be in the form of, where we'll have f of x equals k over x. So our x is in the denominator, okay? Or y equals k over x. It's very important. The x is in the denominator. And we say that this is called inverse variation. In this case, as x gets larger, y will get smaller, and as x gets smaller, y will get larger. We also can say that y varies inversely with x. And again, the number k is still the constant of variation. So what are some situations where we might see inverse variation, some real-life situations? Well, the time it takes to harvest a crop and the number of people picking the crop. If you have more people, it'll take less time because many hands makes light of work. So more people, less time. The number of rabbits and the number of foxes in the field. The more foxes in the field, the fewer rabbits, because of course the foxes are eating the rabbits. And the fewer foxes, the more rabbits, because they don't have as many predators. the balance in my savings account and the number of days of vacation typically for me. The longer I'm on vacation, the less I have in savings. And if I don't go on vacation, I get to keep my savings. But here's an actual computation problem. So here we have the time, t, so we're going to use the letter t instead of x's and y's. So we're going to have the time t it required to drive a fixed distance varies inversely as the speed r. So we're told that it's variation, and we're told that it's inverse variation, not direct variation. And we're given some data. It takes 5 hours at 60 kilometers per hour to drive a fixed distance. So we're given our t and we're given our r here. And now here's the question: how long would it take to drive that same distance at 40 kilometers per hour? So now it's not a matter of, the question isn't find the constant and write the equation. This is, you're going to have to do both of those things, and then you'll use that equation to answer this question. So, first of all, since it says it varies inversely, we know it's going to be, and we have our letters in the proper order here, t equals k over r, and then we put in that data, the 5 hours and the 60 kilometers per hour, and we now solve for k. We see that k is 300. From that, we can write the equation of variation. Now that we have the equation of variation, we are going to answer the question given that we have an r of 40 kilometers per hour. And we find that the time is going to be 300 over 40, simplifying that. And because this is a real life, or supposed real life situation, improper fractions aren't what we want. We'll want a mixed number. It makes more sense. How long would it take to drive that same distance? Well, it would take 7.5 hours.